Unit 2 Remediation Guided Practice. So we're going to go ahead and get started as far as what you saw on the previous test. And so you see the first thing is you need to be able to define your variables. And so what it says for each question, you have the given and the unknown sections. So the first thing you need to realize is that we're going to be doing the guess method for these three things. We're not actually solving them at this point. We just want to identify what each variable is. So the first thing you do says the airplane is initially at rest. Rest tells me it's not moving, so what I know is the initial velocity is 0. Accelerates at, you have to be careful when you see accelerates, because a lot of times they'll say accelerates to and then give a velocity, or accelerates for and give you a time or a distance. But this one actually does give you the rate of acceleration. You know that because of the units, meters per second squared. So you can say acceleration is 2 meters per second squared. In addition to that, it says 100 meters, and 100 meters is the distance or the displacement. So 100 meters. And then finally you have, it says, what is the final velocity? So when you say, what is the final velocity, that would be your question mark. And the one thing that you don't have and don't care about is going to be, at this point, the time. So you would say, time is what I don't care about. On the next one, it says a student moves on an electric scooter at a constant 10 meters per second for 50 seconds. So as soon as you have a constant velocity, you know that it is not going to be if dat anymore, and instead it's just going to be your v, your d, and your t. Now it's up to you to go ahead and figure out that this is going to be 10, this is going to be 50, and this is going to be your question mark. On the last one, whenever we do our final answer, it's going to be, you have an initial velocity of 20, a final velocity of 0, a time of 1.2, the acceleration is what you're looking for, and you don't know the displacement. So it's up to you to be able to get these particular answers. It's really important that we put our units there as well. But you need to be able to get these answers right here from this problem. If you can't get the same answers from here, then you need to go ahead and consult with your teacher to see what's going on. Okay, next it says using a constant velocity graph. A constant velocity graph is a better way of putting this is it's a displacement graph, or a distance displacement versus time graph. Okay, it's not really a constant velocity graph, but because there's no acceleration here is really what we're looking for. Okay, so the first thing it says, okay, what is the displacement of the object after 1.5 seconds? So what I would do is I would go here to 1.5 seconds, I would draw a line up, I would draw a line over, and when I do that, I would get about 1 meter. It might be a little bit over 1 meter, but I'm going to say 1 meter. At what time will the object be 5 meters from its starting position? I would take 5 meters, I would draw a line across and draw a line down, and it would be 4 meters. Now you also have to look and say, okay, well, if you keep going, there's another point at which it's going to be 5 meters, and that's going to be right here, which is 8 seconds, or excuse me, 8 meters. So there's actually two answers to II. And then finally it says, what is the average velocity between 3 and 5 seconds? If you're trying to find the velocity in a displacement versus time graph, remember velocity is displacement divided by time. Or in this case, my rise, which is my y, over my run, which is my x. And that's another way of saying the slope. So what you would do is you would find the slope between 3 and 5 seconds. So if you look from here, it goes up 6. So I have a rise of 6, and I have a run of 2. Or 3 meters per second. Now, it's up to you to be able to get these answers on the next one. So you should get something like 5 meters, 3 seconds, 9 seconds, and minus 2 and 2/3 seconds. Actually, minus 2 and 2/3 meters per second, or minus 2.67. Okay? So it's up to you to be able to get these answers from this graph. Now we're talking about accelerated motion graph. More commonly, you're going to see this as a velocity versus time graph. The first one says, what is the initial velocity of the object? Whenever you're looking for the initial velocity of the object, you're looking for when the time is 0, what's the velocity? And in this case, it's 0 meters per second. Next it says, what is the velocity after 6 seconds? So I take 6 seconds, and I can read it up, and I can say, okay, going across, it looks like it's something around 1 meter per second. Now, the reason why I can do that is because on the y-axis it is the velocity. So when I go to 1 second and go across, that's telling me what the velocity is. That's why it's really important that you always check what the value of the y-axis is. Is it velocity, is it displacement? It makes a big difference in how you interpret the graph. Now the next one says, what is the acceleration? Now remember, acceleration is the change in velocity over time. So when I change velocity, what I'm talking about is my rise in the y. And when I talk about time, it's my run in the x. So when I find the slope of a velocity versus time graph, this will actually give me the acceleration. So I look between 2 and 4 seconds. And when I do that, my rise is 0 and my run is 2. So 0 divided by 2 is 0 meters per second squared. So at this point, there is no acceleration. It would be moving at constant velocity at that particular point. Okay, the last part, it says, what is the displacement at 10 seconds? So at 10 seconds, I want to know what the displacement of this entire graph is. Now this graph is really nice because what it does is it actually tells you the area of each piece already. So you can see they've broken it up into segments. And with those segments, there's numbers written in that are the area. Now you won't always have that, but I just gave that to you on this one so you can kind of see what we're talking about. So for the first one, it says a 3 in there. Now the reason why it has a 3 in there is because that's a triangle. So the area of a triangle is 1/2 the base times the height, or 1/2 of 2 times 3, which is 3. In the second one, it says 6. Now the reason why it says 6 is because the formula for a rectangle is base times height. Well, the base that you have here is 2, and the height that you have is 3, which gives you a value of 6. So you can take the area of the individual pieces and then add them together. Now, one thing that you have to be particularly careful about is that this is a 2, but it's not really 2. It's actually a negative 2, because when you take 2, 1/2 times 2, you get 1, but then you multiply it not by 2, but by negative 2. So because it's below the x-axis, everything below the x-axis is considered to be negative. So since it's negative, you actually have to subtract it. So when I'm trying to find the displacement is the area under a velocity versus time graph. So whenever you do this, you would get something like 3 plus 6 plus 4.5 minus 2 minus 2. Okay, whenever you do this, you should get something along the lines of 8.5. 8.5 meters. Okay, for this one, it's going to be up to you to get these answers. So you should be able to figure out that the initial velocity was 0. You should be able to figure out the velocity after 60 seconds was approximately 50. After 6 seconds was approximately 50 meters per second. That the average acceleration between 2 and 4 seconds was 10 meters per second squared. And you should be able to figure out that the total displacement after 8 seconds is 170 meters. Now, if you can't get these answers or if you have questions about them, please make sure that you see your instructor before you do your independent practice. Next, we have our constant velocity calculation. Our constant velocity calculation is the one in which we're only going to use the formula v equals d over t. The reason why is we only have one velocity. If we have one velocity, we have no reason to use vf's and vi's because they just end up being the same number. So because of that, we can now go ahead and say, what is the displacement of a marble traveling at 8 meters per second for 12 seconds? So I'm going to do my given. I'd say velocity, distance, time, and my velocity in this case is 8 meters per second. My time in this case is 12 meters per second. My distance is what I'm looking for, so I'd use the equation v equals d over t. I would then plug in 8 for velocity. I'd leave d alone because I don't know what that is, and then 12. Now once you get to this point, you have to solve for d. Since d is divided by 12, you don't want to know what 1/12 of d is, you want to know what d is. So instead you would multiply both sides by 12. You have to do it to one side, you have to do it to the other to make sure you maintain your equality. Those cancel, and you get d is equal to 96 meters. Now, the next one is very, very similar. It says how long. So when it says how long, that means you're going to be looking for time. But the big trick here is this. You don't have it in meters per second anymore, which you really do need it in. It's in 20 miles per hour. So you're going to have to convert 20 miles per hour into meters per second. And how you do that is you convert 1 hour to seconds. Okay, just like so. And you would convert 1 mile to meters. When you multiply this out, you're going to get your new velocity. If you convert correctly and plug it into the formula correctly, you should get an answer of around 1,350 seconds. Okay, the last one, you should be able to figure out that the velocity is about 33 meters per second. Next, we have if-that calculations. Now, if-that calculations refer to the initial velocity, final velocity, displacement, acceleration, and time. And what that actually does is it's just a nifty little acronym showing you all the variables that are associated with accelerated motion. So it says, how can you determine if you should use constant velocity formula or if-that? Okay, you will always use if-that if it says initial velocity or final velocity, or there's a change in velocity, or if there's an acceleration. Anything along those lines automatically tells you if-that. If there is one single velocity, or it says constant velocity, that right there is your constant velocity. So next it says use the kinematics motion equations and if-that to answer the questions below. It says a car is initially moving at 20 meters per second and comes to a stop in 235 meters. How long does the car take to come to a stop? So the first thing we need to do is our given. We would say our initial velocity is 20. Because it comes to a stop, we know our final velocity is 0. We know that the entire process takes 235 meters. Okay, we know that we do not know the acceleration, and we do know that we're looking for the time. So because we don't know the acceleration, we cross that out and we look for the equation that does not have acceleration in it. And the equation that doesn't have acceleration in it is d equals 1/2 vf plus vi close t. So you would plug in and you would say 235 equals 1/2 20 plus 0 t. At this point, you can go ahead and solve. You can say 20 plus 0 times 1/2 would be 10. So now you have 10t, and then you have 235 on the other side. You would divide both sides by 10, and in doing so, you would get the time as 23.5 seconds. Okay, the process is very, very similar in part B. The only difference is in this case, you don't know final velocity. So you would choose your equation based on the fact that you don't know final velocity and you don't really care what final velocity is. If you do this correctly, you should end up getting a value of about 0.44 meters per second squared. Okay, next, it says a car is initially moving at 10 meters per second and comes to a stop in 2.4 seconds. What is the acceleration during that interval? When you do this, you should end up getting a value of about -5 meters per second squared. The final thing we have to look at is called relative velocity. Now remember, velocities are relative to the observer. In other words, how you see a motion depends on where you are in observing the motion. So you have a student that walks at 3 meters per second in a straight line. So they're going 3 meters per second this way. Okay. The student reaches a movable walkway that is moving at 2 meters per second. So you have your student that's walking, and they're walking at 3 meters per second, and then all of a sudden the floor starts to move in the same direction at 2 meters per second. So to me, standing over here, how does it look like this person is moving? Well, since they're moving in the same direction like this, the floor is moving and they're moving relative to the floor, you would say that the velocity ends up being about 5 meters per second. So now the question is how far will the student travel in 5 seconds? This is your one velocity. So that's your constant velocity. So you'd say v equals d over t. And when you solve, you end up getting the distance is about 25 meters. Finally, it says you have a movable walkway that's 100 meters long. How much time does the student save by walking on it? So the thing that you would say is you can solve for time using v equals d over t in 2 different ways. You can do it with a velocity of 3 meters per second, which is their original how fast they walk without the movable walkway, and your 100 meters. And you can also solve for it with 5 meters per second. When you do that, you should end up getting a final answer of about, it ends up being about 13.3 seconds. Remember, if you have any questions about this guided practice, or you need any help or you can't get the answers, please make sure that you talk to your teacher before beginning the independent practice.